Welcome dear students, welcome to Ford Public School e-learning class 8. This is your chemistry subject. You're learning chapter number 2, that is structure of atom, and I'm your teacher Yamna Khan. So the topic that we are going to discuss today is electronic configuration. Take out page number 48 of your books. So let's start our topic, that is electronic configuration. Now, what is the definition of electronic configuration? The distribution or arrangement of electrons around the nucleus in orbits or shells is called electronic configuration. It means when you distribute or arrange, means आपस में electrons, each and every atom is having electrons in them. So the arrangement of electrons in the orbits, shells or energy levels, इनमें से जब आप electrons को arrange करते हैं accordingly, that is called the electronic configuration. Electrons are distributed around the nucleus in various orbits or energy levels or shells. These orbits are numbered as 1, 2, 3, 4, 5, 6, 7 up to so on. These orbits are represented by K, L, M, N, etc. You've already learned that in Bohr's atomic model, and he started this a numbering of the shells, and he gave them names K, L, M, N, etc. Now the maximum number of electrons in a particular किसी भी ख़ास atom को अगर आप लें, उसमें अगर आप maximum number of electrons देखें in the orbits is given by the formula 2n square, where n is the number of shell, that is 1, 2, 3, 4 up to so on. So this is the basic formula in which you're just going to put the number of shell so you can find the number of electrons in that shell. So the maximum number of electrons in the first, second and third orbit are 2, 8 and 18 respectively. Let's see how. Here we have the names of the orbits, that is K, L, M, N and O. The formula is 2n square. We're just going to put the number of the shell. Here we have the first shell, so we are going to put 1 instead of n here. 2 multiplied by 1, we get 2. It means 2 electrons can be accommodated in the first shell. As you can see in the K shell, we are having 2 electrons. Alright, now moving on to the L shell, 2n square. Then we are going to put the 2 number as we have the L shell in the second number. Then we get 8, so it means 8 electrons can be adjusted in the L shell. Similarly, M, put the 3 as it is the third shell, you get 18. It means 18 electrons can be adjusted in the M shell. Similarly, N is having 32 electrons and O is having 50 electrons. You can see it in the diagram. K is having 2, L 8, M 18 and N 32. Now take out page number 49. To understand the concept of electronic configuration, we need to learn what are the subshells. First, we are just going to learn the S and P subshells. So first we are having the introduction about the shells or orbit. You have already learned that in the Bohr's atomic theory. According to Bohr's atomic theory, electrons are revolving around the nucleus in one of the fixed circular paths. They are called shells and orbits. Each shell has a fixed energy. You already know that. These orbits are also called energy levels. Each shell is described by n value, that is n is equal to 1, 2, 3, 4 up to so on. Now, as n value increases, the number of shell increases, the distance of the electrons from the nucleus increases and the energy of the electron also increases. All of this is explained in the Bohr's atomic theory and we've already done that. Now moving on to the second topic, that is the subshell. Here we have a shell, then we have its distribution. It is distributed into the subshells. So a shell or energy level is divided into subshells or sub-energy level. मतलब shell होता है और shell को हम divide करते हैं into the subshells or sub-energy levels. N value of a shell is placed before the symbol of a subshell. What does it mean? The N value, which is 1, 2, 3, 4 up to so on. For example, we are taking 2, is placed before the symbol of the subshell. For example, here we have the subshells S, P, D and F. For example, I write P, so it is written like this. The N value is written before the symbol of the subshell. So it shows that we are having P subshell, in which shell? The second shell. Alright. Now here we have the 4 subshells. The subshells are represented by S, P, D and F. These are spectroscopic terms which stands for S for sharp, P principal, P, diffuse D and fundamental F. So S, P, D and F are spectroscopic term, and spectroscopy is the study of spectrum. You already know about spectrum. We discussed it previously in the Rutherford's atomic model. Now we'll move on to the shapes of these subshells. First one is S subshell with 1 orbital. So S subshell is having circle, that is the spherical shape. You can see it is only 1 orbital. Now the next one is P subshell with 3 orbitals. As you can see, there are 3 orbitals and the shape of these is dumbbell shape. You know what is dumbbell? Dumbbell is used for muscular exercises. So the shape of these orbitals is just like the dumbbell. So here we have the 3 orbitals, that is Px, Pz and Py. You can see that there are 3 axes, x axis, y axis and z axis. In the Px, the lobe is going to be on the x-axis. This is the lobe, or this is the dumbbell shape. So the shape is going to, this is going to come on the x-axis. Now we have Pz. Now the lobe is going to be formed on the z-axis. Then this is Py. So the lobe is going to be formed on the y-axis. So these are the 3 orbitals of the P subshell. Then we have the D subshell and F subshell. You can see the F subshell has 7 orbitals and it is very complicated shape. So they cannot be discussed on the in the book. They are 3D structures, so they are very difficult to be explained. So I'm just going to tell you the names of the D subshell. That is, we have the 5 orbitals and we have dxy, dyz, dzx, dx square, y square, and this one is dz square. So you're just supposed to learn the names of these subshells. You're not supposed to learn their structures. Now let's move on to the next page, that is page number 50. Here we have S subshell. So S subshell can accommodate a maximum of 2 electrons. P subshell can accommodate a maximum of 6 electrons. D subshell can accommodate a maximum of 10 electrons and F subshell can accommodate a maximum of 14 electrons. Underline them, you need to learn them. S subshell 2 electrons, P 6, D 10 and F 14 electrons. Here we have the table in which it is showing that the shells are having the number, how many electrons are adjusted in them, and in which subshells how many electrons are adjusted in these subshells. So according to the 2n square formula, you have already found out the number of electrons in these shells. Let's find out the number of electrons, the number of subshells in these shells. So the K shell can accommodate only 2 electrons. That is why we are going to add only S subshell. Alright. Now moving on to the L shell. L can accommodate 8 electrons. So how many subshells can be adjusted? We can adjust S and P. As you can see, S is having 2 electrons and P is having 6 electrons. Add them, 6 plus 2 makes 8. So we can accommodate these 2 subshells in L shell. Now look at the M shell. M shell can accommodate 18 electrons. इसमें कितने आएंगे? इसमें आएंगे S, P and D as well. How? S is having 2 electrons. You can see P is having 6 electrons. Add them, and D is having 10 electrons. So if you add them, you'll get 18. So because of the 18 electrons, you can add S, P and D, 3 subshells in the M shell. Now the next one is N shell. It can accommodate 32 electrons. So we can adjust S, P, D and F as well. You see 2 plus 6 plus 10 plus 14. So you will get 32. So we can adjust all of these 4 subshells in the N shell. The increasing order of energy of subshells belonging to different shells is given below. 1s, 2s, 2p, 3s, 3p up to so on. What does it show? It shows that 1s is having least energy, then there comes 2s, then 2p, then 3s. As you move on, the energy of the subshells increases. Now the electrons are accommodated in the energy levels or orbits by using Aufbau principle. What is this principle? Let me show it to you. Aufbau principle is also called the arrow rule, and let me show you how you are going to draw it. First you are going to write 1s, then 2s, 2p, 3s, 3p, 3d, then 4s, 4p, 4d and 4f. Now we are going to draw the arrows starting from the right. Here one arrow, then come again here and again from the right, like this, like this. This is how it's done. Now we are going to write it 1s first, then comes the 2s, then starting from the right, the arrow starts from here, so we are supposed to write 2p, not the 3s. So next will be 2p, after that will come 3s, then come to the right, the arrow starts from here, so 3p is going to come here, 3p, उसके बाद 4s आ जाएगा, फिर उसके बाद देखें एरो यहाँ से स्टार्ट हो रहा है, so you are going to write 3d, then 4p up to so on. So this is how we say that 1s is having the least energy, then there comes 2s, 2p, and when you move on, the energy of the subshells increases. So this is the Aufbau principle which we are going to use for the electronic configuration, the arrangement of electrons. So here is a rule for the Aufbau principle or arrow rule. According to this principle, electrons fill first the lowest energy subshell available to it and then the higher energy subshells. So it means आपने first filling कहाँ पे करनी होगी, 1s में filling करनी होगी, ठीक है, उसके बाद आपने 2s में filling करनी होगी. It's not possible कि आप directly 2s में filling कर लें या फिर 3s में filling कर लें या फिर 3p में filling कर लें. पहले आपने सबसे जो लोवेस्ट एनर्जी लेवल है दैट इज़ 1s आपने यहाँ पे फिलिंग करनी है. देन व्हेन मोर इलेक्ट्रॉन्स आर देयर देन यू हैव टू मूव ऑन टू द 2p. इफ स्टिल यू हैव इलेक्ट्रॉन्स लेफ्ट देन मूव ऑन टू 2p and then 3s then 3p. Alright, so we are going to start with the least energy and then we are going to move on like this. So you can see according to this principle, electron will first fill 1s, then 2s, 2p, 3s, 3p, 4s and then 3d, because the energy of 4s is lower than the 3d subshell. You can see that 4s is having lower energy, so you're going to put the electrons in the 4s then in the 3d. So the electrons are adjusted in the energy levels or the subshells according to their energy. First in the lowest energy level and then you're going to move higher and higher. Now here we have the electronic configuration of first 18 elements, which is done for you on the next page. The electronic configuration of first 18 elements is given below. Now move on to the next page. That is page number 51. You can see that we have first 18 elements with their symbols and their atomic numbers, and here we have the electronic configuration. You can see that we have K, L and M shell, and here we have the subshells, S subshell, P subshell and D subshell. Now let's see how are you supposed to do the electronic configuration and how are you going to arrange the electrons in these subshells. Electronic configuration of lithium first. Lithium is having 3 atomic number. Atomic number is either the number of electron or the number of proton. So we are going to adjust these 3 electrons in these subshells. We will start with the 1s as the arrow starts from the 1s. We are going to follow the Aufbau principle. So 1s, here we are going to write 2. As you can see that only 2 electrons can be accommodated in S subshell. तो आप यहाँ पे 1s2 लिख लेंगे. अब अगर आप देखें तो 2 electrons आपने adjust कर लिए हैं. कितने electrons रह गए हैं? 1 electron is left because we have 3 electrons. अभी एक electron कहाँ पे जाएगा? आपने इस एक electron को यहाँ पे S में नहीं डालना. Why? क्योंकि S can only accommodate 2 electrons, not more than 2. Less than 2 but not more than 2. तो ये नेक्स्ट इलेक्ट्रॉन थर्ड वाला कहाँ पे जाएगा? नेक्स्ट वन में, दैट इज 2s. सो वी आर गोइंग टू राइट 2s1. नाउ ऐड देम 2 + 1 makes 3. So now this is the electronic configuration of lithium. Moving on to boron. Boron is having 5 atomic number, that is, it means that is having 5 electrons. Let's do the electronic configuration. That would be 1s2, then there comes 2s, 2s2 क्योंकि इसमें 2 इलेक्ट्रॉन्स एडजस्ट हो सकते हैं। अब इसको ऐड करें, 2 + 2 मेक्स 4, इट मीन्स एक इलेक्ट्रॉन बच गया है। ठीक है, 4 आपने एडजस्ट कर लिए हैं, 1 इज़ लेफ्ट। अब ये 1 कहाँ पे जाएगा? अगेन जहाँ से एरो स्टार्ट हो रहा है C2p, तो आपने इसको 2p में नेक्स्ट ऐड करना है। सो 2p में हम इसको ऐड करेंगे, दैट वुड बी 2p1। वैसे अगर आप देखें तो p में यू कैन एडजस्ट अकोमोडेट 6 इलेक्ट्रॉन्स, बट वी डू नॉट हैव मोर इलेक्ट्रॉन्स। आपके पास सिर्फ एक ही इलेक्ट्रॉन बचा है, तो आप इसको यहाँ पे p में ऐड कर लेंगे। Alright, so this was the electronic configuration of boron. Moving on to the next one, that is sodium. Alright, again 1s2 2s2। अब देखिए स्टिल हमारे पास ज़्यादा इलेक्ट्रॉन्स हैं, तो p में हमने कितने ऐड करने हैं? 6 ही ऐड कर लेंगे, 6 इसमें अकोमोडेट हो सकते हैं। अब अगर आप इसको ऐड करें 6 7 8 9 10 इलेक्ट्रॉन्स आपके पास एडजस्ट हो गए हैं। एक फिर भी आपके पास रहता है जो कि आप इस p में ऐड नहीं कर सकते हैं। p कैन ओनली अकोमोडेट 6 इलेक्ट्रॉन्स, यू कैन नेवर राइट p7। ठीक है, सो ये एक इलेक्ट्रॉन जो बच गया है ये नेक्स्ट वाले में जाएगा। अब नेक्स्ट क्या है? 3s है, इट मीन्स आई एम गोइंग टू राइट 3s और 2 नहीं, 2 यहाँ पे अकोमोडेट हो सकते हैं s में, लेकिन आपके पास यहाँ पे कितने बचे हैं? सिर्फ 1 इलेक्ट्रॉन बचा है। 10 ऑलरेडी हो गए हैं, 1 बच गया है, तो मैं यहाँ पे इसको ऐड कर लूँगी। ठीक है, सो दिस वाज द इलेक्ट्रॉनिक कन्फिगरेशन ऑफ सोडियम। Next one is aluminum. Aluminum's atomic number is 13. It means they have 13 electrons in their shells. Let's accommodate them. 1s2. Alright, the next would be 2s2. Then there comes 2p6. Then 3s में भी आपके पास 2 आ जाएंगे। अब काउंट करें, ये 10 हो गए, 11 12 हो गए, 1 इज़ लेफ्ट, 1 इलेक्ट्रॉन इज़ लेफ्ट। अब क्या करेंगे? आप इसको इसी में नहीं ऐड करना। 2 इलेक्ट्रॉन्स कैन बी अकोमोडेटेड, आई एम सेइंग इट अगेन एंड अगेन, यू कैन नेवर ऐड अनदर इलेक्ट्रॉन। ठीक है, जितने अकोमोडेट हो सकते हैं आपने उसमें उतने ही ऐड करने हैं। तो ये नेक्स्ट कहाँ पे जाएगा? 3p, 3s के बाद क्या आ रहा है? 3p आ रहा है, तो आपने इसको कहाँ पे डालना होगा? 3p में डालना होगा। जितने इलेक्ट्रॉन्स बच गए हैं उतने ही डालने हैं, ज़्यादा या फिर कम नहीं ऐड करने। सो हमारे पास यहाँ पे ये 12 बन रहे हैं, 13 है टोटल, एक इलेक्ट्रॉन बच गया है, सो आई एम गोइंग टू राइट 3p1। सो दिस वाज द इलेक्ट्रॉनिक कन्फिगरेशन ऑफ एल्यूमिनियम। Electronic configuration is very easy. You just need to learn the number of electrons accommodated in s, p, d and f orbitals. Now come to the next page, that is page number 52. We are going to do this test yourself. Look at the first one. Sodium has 11 protons and 12 neutrons. Write the electronic configuration of sodium atom. We are already done with the electronic configuration of sodium atom, but there is a trick. You can see there is 11 protons. आपको electrons given नहीं है. But we already know that electronic configuration is based on the atomic number, and atomic number is either the number of electron and number of proton or number of protons. ठीक है, तो या आपने number of electrons लेने हैं या आपने number of protons लेने हैं। अगर आपको 11 protons given है, it means it is simple that if there are 11 protons, it means there are 11 electrons as well. So it means that you have to accommodate 11 electrons in the SPDF shells. All right. Now moving on to the next one, that is potassium has electronic arrangement of 2881. ठीक है, so it means कि ये electronic arrangement है, तो it means ये electrons हैं आपके पास। ठीक है, अगर आप इनको add करें 2 + 8 + 8 + 1, you will get 19. ठीक है, so these are basically the electrons. First one question is what is the proton number? अब आपको यहाँ पे ऑलरेडी पता है कि you added them as is the electronic arrangement. इसका मतलब है कि आपको electrons given है, तो जितने electrons होंगे उतने ही protons होंगे, because protons, number of proton is always equal to the number of electron in an atom. ठीक है, तो 11 electrons है, it means कि protons 19 electrons है, it means आपके पास 19 protons ही होंगे. So this one is done. Moving on to the next question, that is proton. Draw the electronic structure of potassium. When you draw the electronic structure, it would be like this. All right. First shell can accommodate only 2 electrons. ठीक है, you have to go back and see the number of electrons accommodated in each shell, that is KLMN. all right, so first shell में आपके पास 2 आ जाएंगे, next one में 8 आ जाएंगे, another में भी 8 आ जाएंगे। ठीक है, 19 electrons हैं और एक आपके पास outermost shell में आ जाएगा। That would be the electronic structure of potassium. The next one is write the electronic configuration of nitrogen, phosphorus and argon. All right, we are already done with this in the previous on the previous page, so you can practice it from there, and this is your assessment. You have to do this on your rough notebooks. So this was the end of your lecture. I hope you understood the lecture well. Thank you. Stay home, stay safe.